Then let's move on to 5.2. 5.2, logarithmic exponential and other transcendental functions. That's chapter 5. 5.2 specifically, we're going to look at natural log function and integration. Use the log rule for integration to integrate irrational functions, integrate trigonometry functions. Log rule for integration. So as we did it last time in 5.1, we took a derivative of log functions, right? Now we're gonna do antiderivative. So we know the natural log is 1 over x. So in other words, if I wanna go back, so antiderivative of 1 over x will give me what? Natural log of absolute value of x. Because remember, natural log cannot be negative number because our graph looks like what? Like that. So we only have positive numbers, okay? So that's why you're going to have absolute value of natural log of x plus c. This is the same thing, but say if your function is, say u equal to say x squared plus say 2x, then I need to have a du to be 2x plus 1 dx. That's what they mean by u. U in this case is has other than just the x itself. So it has like derivative that associate with the u, in other words, other than 1. So this is how you write it down, in other words. Let's look at the example. So if you have integration of 2 over x dx, that means I can just bring out the 2 in the front, or 2 in the front. So I have 1 over x dx, and you know what to do. So 1 over x is the same as natural log of x. And you have 2, and just bring over there, and then you're done with it. All right. But if you would say, okay, I want to even more condense even more. So which means I can put your 2 into your power of x. So I can make it into natural log of x squared plus c. In this case, I can drop the absolute value because x squared is always positive or 0, positive or 0. So I don't have to put absolute value of x squared because x squared is always positive number. Okay, 0 or positive number. That's why they drop the absolute value there. All right, so if I have this indefinite integral like this, you know what, this kind of problem, you have to do the long division because there's no way we can do this problem without doing a long division. Okay, so because we don't know how to do this problem. So let me do the long division. I mean, they gave you over here. Okay, but I'm gonna show you this problem in a notebook so it'll be a little bit easier for you to see in case you forgot how to do long division. Okay, so let's do long division together. We're gonna do 5.2. But this time we're gonna do long division. All right, the problem that we're gonna do is this. We don't know how to take antiderivative of this kind of function because we haven't learned this. So we need to do something that we know how to do. So that means we gotta take, we gotta do long division. So let's do the long.
No, why would I?
Excuse me? Does anybody have a question? Okay, let's move on then. So we're gonna do long division. Before we do this long division, let's review. Let's practice. I want to look at this one. So if I give you, say, 4 divided by 3, let's do long division. What do? You're gonna put 4, you're gonna put 3 in over here, and then what do? You would think about it. It's like how many 3 goes into 4? Then you're gonna say, okay, it goes in 1 time. So you're gonna put the 1, and what do? You 1 times 3 gives you 3, and then you put right there, right? And then you subtract, and then you get, okay, 4 minus 1 gives me 1. Then you're gonna say, okay, 4 divided by 3 is actually same as 1 plus 1/3, right? Is everybody with me? This one is right here. This one goes right there. All right, is everybody with me? So I want to understand how to do long division. Let's do another one. I want to just make sure that you understand how to do long division because we're using the same concept for the polynomial functions. So if I give you 5 divided by 2, that's the same as, let's do 5 divided by 3. 5 divided by 3. And that's same as, you're going to think about 3. How many 3 goes into 5? You're going to say, okay, it goes in 1 time. Then what do? 1 times 3. 1 times 3 gives me 3. And you put that right there. And then what do? You put the negative sign, which means you put opposite sign and give you 2. So I can rewrite it as 5 over 3 is the same as 1 plus 2/3, right? This one, write it down by itself. The quotient is right there, and this is what? Your remainder. So remainder goes to right there. All right, so we're going to do exactly the same way. We're going to use the same concept. So look at this. When you do the long division for the polynomials, you look at the leading functions only. All right, x squared and x squared. What do I need to do? How many x squared goes into x? How can you make x squared same as x squared? By multiplying by what? 1. So I put the 1 here because x squared times 1 gives me x squared. So let's do that. We're going to multiply, we're going to distribute that one. So x squared times x squared is x squared. X squared times 1 plus 1 times 1 is 1. All right. Now we're going to subtract just like we did our number long division. So this become a negative, that become a negative. That cancel out, you get a 0. You bring down the x. That and that cancel out, then that's it. All right, so I can rewrite this problem as 1 plus n x over x squared plus 1. Is everybody with me? Now I know how to do this problem. So we're going to rewrite this problem. So we just learned. I can write down x squared plus 1 I can make that into 2 problems. All right. The first part is very easy. This part is just the x. All right, second part. This part is the one that you need to do u substitution. So you're gonna say, okay, u is x squared plus 1, du is 2x dx. So I'm gonna rewrite this problem. So I'm gonna say, okay, this is the same as u, I need 2. I don't have that 2, so I will put the 2 in the front. Now divided by 1/2. Okay, so I have 1/2 du. Now, this is just simply a what? Natural log. So I got x plus 1/2 natural log u plus c. So we're done. We'll plug it back into what u is. U is this. In this case, I can drop the absolute value because x squared plus 1 is always positive, not negative. So that's your answer. All right, I want you to go over this one by yourself, okay? Because I want you to understand how to do a long division. Because without the long division, if you don't know how to do long division, you cannot do this problem. So this will be recorded again. So if I want you to look over this again, so you know how to do it. All right, let's go back to our lesson. Okay, anybody have actually questions about the long division? Do I need to go over any extra example with you? If you do, then you need to let me know now before moving on to the next one. Anybody want me to go over long divisions again? All right. So
Can you go back up so I can take a picture of the work that you did, that you just did?
yes. Okay. All right. So I will do another long division because one of you guys asked me to do long division here and here. Okay. Let's practice how to do long division. Okay. Okay. Bernice, did you take a picture already?
Yes, ma'am.
Another long division practice. So if I gave you, it's nothing to do with a natural log. I just want to see whether you know how to do long division, okay? So another example. Okay, so if I give you this, if I give you this problem, okay? In that case, we're going to do just like we did before. We put the numerator inside here, and denominator goes to outside. All right, as I said before, we only worry about this. Okay, only match that. So you're gonna say, how can I make x to be x squared? What do I need to multiply by x to get x squared? Chevian, x times what giving me x squared? All right, anybody gonna help me? X times what gives me x squared?
Is it X?
Exactly, x. Because x times x gives me x squared. So that is gonna be what your quotient would be. So I'm gonna put the quotient in the where the quotient part is. Now what I do, after I do my comparison, now I'm gonna do distributed. So x times x is x squared, so I put it right there. And x times 1 is what? X, I put it right there. Now what I do, just like my regular number long division. After I do that, what I do the opposite sign. So this become a negative, that become a negative. So those two cancel out, that cancel out, so I'm just having a what? 1. As you know, I need to stop that because there's no way you can make x to be 1. So that become a 1, become a your remainder. So this problem, I can rewrite it as x plus 1 over x plus 1. This is equivalent to that. So if I give you this problem as your integration problem, you're going to rewrite it. right, the first part is of course easy. That just become x squared divided by 2. The second part, that is also easy in this case because you're gonna put that to be u, and your du is 1 times dx. So which you have that. So that'll be same as du over u. So you're done. Okay, and then you're gonna say, okay, I need to prove back my u is x plus 1. So I'm done. In this case, you need to have your absolute value there because x can be negative number, then you're gonna have a negative as your argument for natural log, which you cannot do that. Natural log has to have non-negative numbers, okay? So you're done. Does this help you? Or do I need to do another example?
Can you go back down a little bit? Well, up. Okay.
All right. And I want you guys also watch videos, okay? And then work with your peer tier leaders. All right. So is everybody good? Or do I need to give you another example? Is everybody good? What about the long division? So long division of the polynomial is the same thing like long division with the numbers. You do same concept. You're applying same concept, but now you're doing with the variables instead of just a number. All right. So that's that. Okay, the guidelines for integrations. Okay, you need to know your basic integration, of course. All these basic integrations, the entire power rules, all these trigonometry functions, you need to kind of memorize it. Okay, and then also you need to kind of recognize what to do. Like this kind of problem, you look at this problem, you're gonna say, there's no way you know how to do this problem. That means you got the long division. All right, so this kind of problem, if you have this, okay, when you have this problem, you're gonna tell yourself, well, you know what, this looks kind of complicated, but actually it's not. But if you recognize what is your u and what your du, then then it makes sense. Okay, so when they give you problems like this, and they say differentiate the equation, the first thing you're gonna do is kind of like what? You multiply by dx on each side. So you only have a dy is equal to 1 over x, natural log of x dx. Since you want to find the solution, that means you got to take what antiderivative of each side, because that will gives me y, right? So y is equal to something, then that's your solution. So let's just see, what do I need to do? In this case, you're going to think about yourself, okay, if I put u to be natural log of x, what's my du? Du would be what? 1 over x dx, because derivative of natural log of x is at 1 over x dx, okay? So in this case, even though it looks very complicated, if you write it down in terms of u, this problem becomes a very easy problem, because now you have, just think about this one. This is the same as, so dx and 1 over x, that become a du. So I have du over u. All right, you know what to do about du over u? That's just natural log. That's just natural log u plus c. So I'm gonna plug back into my natural log, my u. So in that case, natural log of u plus c. So yes, you can have a natural log twice. Okay, that's fine. That's your answer. Okay. So that's why you have natural log of c. All right. So the chapter 5 is not hard, but it's very different because you haven't done log and exponential functions before. But their derivatives and their antiderivative is much easier than regular functions. So just you need to recognize it, how to do it. Like if I give you, take antiderivative of tangent x, the first thing you have to rewrite the tangent as just in terms of sine and cosine. So tangent is the same as sine over cosine x. In this case, you're gonna put u to be cosine x. All right, then what's your du? Du is what? Negative sine x dx, right? So, well, you have a sine x dx right here. Only thing you need is what? Put the negative sign in the front, and then you gotta put the negative in the outside of the integrations. So you got this one, and you're done. And I can rewrite it like this. And I got done. So this is a very good example for your trigonometry function. All right. So make sure that either you remember this or you need to apply this. Because when you come over here, you see that all these trigonometry functions, you need to memorize this. Either you memorize it or you need to derive this. All right. You already know this one. You already know that one. Now you learn this. Tangent is the same as negative. You see my screen? Okay, great. So for number 4, yes, if you want to, you can do long division. But because your denominator is only single term, it's better to just separate into 2 terms. But if your denominator is more than a single term, like 2 terms or 3 terms, yes, you have to do long divisions. But number 4, you didn't have to do long division because your denominator is a single term. But if you decide to do long division, yes, you can do it. For example, let's look at it. X squared minus 8 and 8x. And you're gonna tell yourself, okay, how can I make 8x go into x squared? And you're gonna say, I need to multiply by 1/8x. So you were gonna just multiply that, you get a x squared minus, you get a what? 8x over that. So, oh, that's it. So you only have that, right? So then subtract, then you get 0 and you got left over the 8. So yeah, you only have 1 term, so that's it. And then you got -8, bring it down, you gotta bring it down to -8. Then you're gonna have, your answer is 1/x plus -8 over 8x, and 8 and 8 cancel out, so you have a 1/x minus x. That's what you have. So which is the same as, oh, excuse me, that should be minus, right? Because you have a minus in the front. So this is negative and negative. Thank you. All right, either way, you get the same answer. But as you can see, if you have a single term as a denominator, it's better to just separate it instead of doing a long division. All right, this case, yes, I have to do long division because my denominator is not a single term. So first thing, when you do this kind of work, you have to show your work. So you're gonna start with showing a long division. 2x squared plus 9x minus 1 divided by x minus 5. And you're gonna tell yourself, okay, how am I going to make x to be 2x squared? You're gonna say, okay, I need to multiply by what? 2x, because 2x times x gives me 2x squared. After that, you're going to do distributed. So you're gonna put the 2x squared minus 10x. All right, just like a number long division, I'm gonna do opposite sign. So this become a negative, that become a positive, so that cancel out. Now I have 19x, bring out the -1. All right, you still can do one more time. You check this and you check that. So x times what give you 19x? Plus 19, right? 19 times x give you 19x. Now I'm going to multiply 19 with this. So 19 times x is 19x. 19 times 5 is what? It's 95. Am I right? 19 times 5. Okay, so now I'm gonna do subtract. So this become a negative, that become a positive, that cancel out. So I have 94 minus 1, so we got a 94. So I can rewrite my problem now. So I have, this problem is the same as 2x plus 19 dx plus I have 94 over x minus 5 dx. All right, this is your remainder. That's your quotient. So quotient goes by itself. And then this is just the anti-power rule. So you get a what? X squared divided by 2 plus 19x plus, and this is also same thing. This is an easy problem because your u du is just the 1x dx. So I have 94 natural log x minus 5 plus c. All right, so this one is a little more complicated. So if you want me to do this problem in a notebook, I can do that. Okay, so will you give me the, Ethan, will you read it to me? Okay, hold on, let me write down the problem in here. So what's my, that's the number, what number is that homework problem? Is it 5.5? 5.2, what number? Number is 5, okay. So I'm gonna do number 5 again, you guys, okay? So the problem is, read it to me. What's the my problem?
2x squared plus 9x minus 1 divided by x minus 5 dx.
Okay, so I gotta do long division first. So this is what you have to show me at your work when you take your exam. For example, if I give this problem as your exam, then you need to show me the long division first. So let's do long division. The first thing is I'm only gonna look at this, I'm gonna look at that, I'm gonna say how I'm gonna make x to be 2x squared. So you're gonna say I need a 2x, because 2x times x gives me x squared, 2x squared. After that, you're gonna do distributed. So 2x times x is 2x squared, 2x times negative 5 is negative 10x. Okay, I want you to watch this and do it, practice this so you can do your problems. Next thing, I did a sign change. So I have now 19x, bring out the negative 1. So there, that's there. Now you're gonna say to yourself, okay, I cannot stop yet because they're not, I can still make my x to be 19x. So by multiplying by 19, because 19 times x gives me 19x. So now this time I'm gonna distribute it. A 19 to this. So 19 times x is 19x. 19 times negative 5 is negative 95. And I'm gonna do sign change. So this become a negative, that become a positive. So that gives me 94. So I can rewrite this problem as 2x plus 19 and plus 94 over x minus 5 dx. So I'm gonna say, okay, I'm gonna make it into 2 parts. So I have 2x plus 19 dx plus I have 94 x minus 5 dx. first part is just the easy one because you're just doing an entire power rule. So this just become a 2x squared divided by 2 plus 19x. The next one, you're gonna say u is equal to x minus 5, du equal to 1 dx. So I can just rewrite this problem as 94 in the front. I have du over u. So I have x squared plus 19x plus 94 natural log of u plus c. So we just plug back in. U is equal to x minus 5 plus c. So you're done. All right. Is everybody good? All right, do you see it? So if you need to take a screenshot, go ahead and do so, or watch the video again. All right, let's moving on to our homework problem. So that's how you got this. All right, you practice number 6 same way. Okay, number 7, as you can see, you can put the u to be natural log of x and du to be 1 over x dx. Then you can rewrite this problem as you see, that's your du. Okay, then you have a u to the third and du. That's just a power rule. So you have u is natural log of x to the 4 plus divided by 4 plus c. All right, so I need to see all this step, class. Number 8 is the same way. All right, you know cotangent, you can memorize it, or you can use by looking at that, okay? So over here, you can say, if it's tangent, you're gonna write down, you gotta rewrite the tangent as a sine over cosine first. Right, so this problem, rewrite this problem as a theta, sine 7 theta. All right, it's theta square, theta square. All right, so you're gonna say, you know what that is. You're gonna say, okay, my u is equal to cosine 7 theta square. My du is equal to negative sine 7 theta square times 2 theta d theta. Because you gotta multiply, you gotta take a derivative of theta square, which is 2 theta. Let me write down a little bit clearly so you can see. Du is negative sine 7 theta square times 2 theta d theta. All right. So you're gonna say, okay, I have a 7 square right here, sine 7 theta square, and I have a d theta, I have a theta, I don't have a 2, so I need to apply 2, and I put the 1/2 in the front. So I have 1/2. Now I can do du and u, that just simply become a natural log of u plus c. And you can put back the natural log, the u. What's my u? U is cosine 7 theta square plus c. All right, so you got that. Oh, 7, excuse me, you got the 7 over here. So you need to multiply this by 7. Okay, right here, this 7, I forgot about my 7 right here. 7 times 2, which is what, 14. So now sine 7 theta squared times 14 theta d theta. So I need to put actually 14 here. Okay, the 7 times 2. I forgot to multiply the 7. So 7 times 2, which gives you 14. So your answer should be this. All right. All right, let's see. So all your homework problem is kind of like the same way. Like this one, if you do that, if you put u to be secant x 9, du is secant x and tangent x d theta. So just simply this become a so you got natural log over u plus c, and you just replace this as your u. So even though it looks complicated, but if you do the u substitution, that problem become a simple problem. All right, so pretty much everything is the same way. I don't see much difference. Okay. All right, so this chapter, this section is short, but it requires you to do a little more work because it's asking you to do a lot of long divisions. If you don't do long divisions, especially like if you have trigonometry functions, you can just refer to this. This. They expect you to know this so you can utilize this. All right. Any questions? Any questions from today's work?
Can you do 5 from 5.1?
Okay, 5 from 5.1. Okay, this is the one that I did in class, but I would do it again. Were you there, Davian, when I do this problem? Okay, so they gave you this. So I have to use these numbers only, not the number from your calculator, but the number from this. So natural log 0.25 is the same as natural log of 3 divided by 5.75 is the same as 3 over 4. And then you're going to rewrite it as natural log of 3 minus natural log of 4. And then you want to say natural log of 3 minus natural log of 2 squared, because 4 is the same as 2 squared. So you rewrite it natural log of 3 minus 2 times natural log of 2. I'm using a log expansion properties. So now I know natural log of 3 is 1.0986 minus 2 times 0.6931. So when you multiply all that, you get negative 1.3862. Is this the one you have questions? Which one you have questions? Which part? A, B, C, D, which one?
It was all of them, but I guess you do them the same way.
Okay, so you want me to do like letter C now?
You can.
Okay, so did you understand how I did my letter A? So you're gonna apply same concept. You're gonna break it into that number into 2 and 3, because they gave you natural log of 2 and natural log of 3. So those are the two numbers you can only utilize it. So for example, if I do C natural log of 3 square root of 18, and you're gonna say, okay, this is the same as natural log of 18 to the 1/3. Okay, then you're gonna say, okay, that's the same as 1/3. Or you can say, what do you know about 18? 18, I can rewrite as what? 2 to the how many? 2 times 2 times 2 times 2, what's that equal to? 16. Or so I cannot do that. So you can rewrite as 18 as what? Think about it in terms of a 2 and 3. 2 times 3 times what? 3 is 18? Am I right? 2 times 3 times 3?
Yes.
Okay. So I can rewrite it as natural log of 2 times 3 times 3. So that means same as net 1/3 natural log of 2 plus natural log of 3 plus natural log of 3. So it'd be 1/3. Natural log of 2 was what? 0.6931 plus 1.0986 plus 1.0986. When you do that, you get equal to what? 0.9634. So you need to break into that number to 2 and 3. All right. Any other homework problems you want me to go over?